Unlock full body expressive capture with the 53-point marker set. This comprehensive protocol provides the anatomical detail needed to drive complex digital characters and meet the demands of animation and advanced motion analysis. For the 53 markers model, we started from the head. 2 markers on the front head and make these 2 markers at the different heights. Same as the back of the head. 2 markers at different heights. One marker on the top of the head. This one should higher than the other 4 markers. Then we put 2 markers at the front and the back of the single shoulder joint respectively. Same as the other side. One marker at the middle of the clavicle bones, which is about the position of the zipper. One marker at the lower edge of the sternum. One marker at the base of the back of the neck. Next, one marker at the center of the back, which is about the same level of the front one. Then to the west. 2 markers at the front of pelvis. Two markers at the back, which can be a little higher than the front one. Also 1 marker at each side of it. These 2 markers at the side need to be asymmetric. One close to the front and another a little bit close to the back. Next, go to the arm. 1 marker at the elbow joint. 1 marker on the lateral side of it. 1 marker at the medial and 1 at the lateral side of the wrist. 1 marker at the index finger and 1 marker at the little finger. And these 2 markers on the hand should not in the same line. Same as the other side. Then 1 marker at the upper arm and 1 at the forearm. We still follow the higher left, lower right rule. Then go to the leg. 1 marker at the lateral side of the knee joint and 1 marker at the upper side of it. 1 marker at the lateral ankle. Repeat on the other side. 1 at the top toe. When you're bending your forefoot, 1 put medial and 1 put lateral side of it. 1 put at the heel. Same as the other side. Similarly, 4 markers on both thighs and shanks, and follow higher left, lower right. Then all 53 markers have been put. Different was the Helen Hayes model. If you want to deal with the data in the game CG or the 3D animation, you need to apply 53 markers model. When you do the calibration, the up-axis needs to be y-axis, which is different from Halen Hayes. Before we create the body, the human body needs to face to the positive direction of z-axis and raise both arms horizontally to do the T-pose. When we can see all the 53 markers on the human body, we can click freeze and create a body by right-click. We choose baseline plus toe headband model with 53 markers and name the human body. There are 3 versions of 53 marker model. V1, the span is curved, V2 is straight, and V3, not only the span, but all the skeletons are straight. Usually, V1 is used for animation, V3 is for robotics, and V2 can do both. When we click on freeze, we can see the model is successfully created. If we want to record the data, we can name the file first and click record. Then we go to edit mode and open the cap file we just recorded. Go to file and export FBX or BVH file based on what we need. To open in the Motion Builder, Maya, 3ds Max, UE, etc. If we only want the data of markers, we can export C3D or TRC file and further edit it in Motion Builder. When we export FBX, we can choose Insert the Calcium Model Pose Skeleton at the first frame, and the other functions listed can be added and exported optionally. These file types can be imported into other animation software. If we want to live sending the data to other software like Motion Builder, Maya, Unity, or UE, we can go to Data Custom Pane and open SDK function. Then the other software can real-time receiving the data. Our software can connect some third devices to achieve co-use. For example, the force plate, EMG, and gloves management. We also provide different plugins to other software, which is shown here. Different SDKs for various computer operation systems, and VRPNs for ROS 1 and ROS 2.